Hello, this is Elif Öztürk. I'm gonna answer chapter 4's questions, and I could not reach my online access, which is I wanted to read the questions from the book, but I will read in this time the questions from my book. Okay, let's look at the question 1. The question 1 says that what is true about the size and shape of two stick figures? And I can draw a stick, two sticks figure here. And it wants from me to transform this one to the another one. Translate. Okay. And they're totally the same. Their size the same and they're totally same, we can say. The question 2 says that use the arrow tool and drag a point on the leg of the original stick figure. It's a pre-image. Try dragging a point on the arm of the stick figure. What else changes when you perform this dragging? Why? And this is pre-image and this is image. And let's put a point on my pre-image, and as you see that there's nothing change from the second one, which is the image. Question 3. Measure the distance between the endpoints of the left leg of the original stick figure and the corresponding point on the left leg of the new stick figure. What other distance do you think will be the same as this measure? Let's look at distance with the between these legs. The length is 3.75 centimeters, and the length is for the image totally the same. And also we can look at this distance. For example, leg to head, the center, and leg to center. And look at the length 3.51 centimeters and 3.51 centimeters. As you see that they are totally the same size. Okay, make it. The question 4 says that measure several other distances. Select a point on the pre-image stick figure and measure the distance from the corresponding point on the pre-image stick figure. This is for several pre-image pairs of points. Explain why all these distances are the same. And all these distances are the same because I checked the right stick figure because they're probably the same sticks. The question 5. Repeat the procedure to translate a stick figure to create a chorus line of the stick figure and that are equidistant apart. Describe how you choose to do this. Discuss several alternative ways this could be accomplished. We can do many things, like I choose the way that I select all of the shapes like two stick figure. Then I got transform and do the same things. Then I got chorus line. Look at this one. And I go transform. And I can put the distance. Anyway, 10 is better. and there's a chorus line. This is the second, this is the third one. And question 6. Question 6 says that drag a point on the pre-image stick figure. Which other points move? Explain. Drag a point on one of the image stick figures. Which other points move? Explain. Okay, drag a point on my image or pre-image, as you see that. And when I drag a point on the pre-image, it doesn't change anything from these two sticks. And when I drag the middle of one, it doesn't change from these two sticks also. Question 7. Question 7 says that a student in a high school geometry class asked what the 5 and 0 represents. These are the values that were typed in the polar coordinate dialog box to perform the translation. How do you respond? It shows that the qualification. Question 8. I translate the second stick figure to have 3 sticks figure on the screen. What do you notice about the size and shapes of 3 sticks figure? And as you see that this is the third one that I transform it, and they are also the totally same from these 2 sticks. Question 9. How is the location of the stick figures related to the translation vector? Mark vector shows that where is the vector on the shape. For example, when I go to the mark vector, it showed me like FH is a vector, F üssü H üssü is a vector, and F üssü H üssü is a vector too. Question 10. Drag the line segment representing the translation vector so that the tail be corresponding with a point on the original stick figure. Where is the head of the vector located? Y. Actually, we can look at these one. There is chorus line, and yes, as you see that this is the head, this is the tail, this is the head. T is a head, the other one is a tail. Question 11. Use the segment tool to create a segment that joins a point from the original stick figure to its corresponding image point. What do you notice about this segment and the vector? Like before I created it, I created a line segment that joins a point from the original sticks. Then I realized that it does not affect that other image. Yes, this one. Anyway. Question 12. Use the arrow tool to drag the head of the vector points A. What else moves Y? Where it is? Anyway, look at the first one, and I predict that if the tail of the vector is dragged at point A, which one? The point A moves just the point A, then I see that all the same points on the images are moving at the same time. As you see that all these are moving. Question 13 says that Predict that will happen if the tail of the vector is dragged. Drag a point B, what else moves Y? And then I can drag this one as a B. And then the B, and then moves. All these B points are moving at the same time. And also question 14. Mark vector AB by selecting point A and then point B and choosing mark vector from the transformation menu. Select all the original sticks figure and translate it. When does the image appear relative to the original sticks Y? And this is original stick, and then point A, I marked it, and then picked this one, and then translate. It translates to there. And point A, then point B, then I choose the mark vector, then translate. I see that there is another vector which is connecting with the segment AB as yes. Question 15. What do you think will happen when you translate a line segment? What will be true of the image of the line segment? What about a line? Okay, let's draw a line segment there. And we call it, okay, K to L. And then this one says that line segment. This is an image. Translate. There is another 6 eyes. I do see I translated. Question 16. What do you think will happen when you translate an angle? What will be true of the image of that angle? Look at this one. I did draw it before the angle one. I do the same things for the angle. As you see that it's made another angle which is the same size. Question 17. What do you think will happen when you translate two lines that are parallel to each other? What will be true of the image of those parallel lines? When I translated two lines that are parallel to each other, I see that on the sketch there is just one line which is parallel to the another one. Look at this one. I drew it before, where it is. First of all, let's draw this one. Let's find the parallel one. Parallel line. We can now do the literal AJ. And this is the parallel of one, and pick two of them and then translate it. And there is just all of them and go to the transform, and yes, two of them are translated. Question 18. You have had the opportunity to perform several different translations. Based on your experiences, describe a translation. Be sure to explain what stays the same and what changes. I had the opportunity to perform many different translations. based on the experiences. I think translation is a term that moves an object at a certain distance. In a translation, every point of the object must be moved in the same direction and for the same distance. When you are performing a translation, the initial object is called the hyperimage and the object after the translation is called the image. Okay. Question 19. Students often have difficulty to reasoning about vectors. Because representations of vectors and rays are very similar, students confuse these two objects. Describe how you could assist students in understanding differences between vectors and rays. I would like to explain with this way, which is vector is the direction and the magnitude, for example 10 meter northeast. A ray is just direction and the starting point, and it has infinite length. A ray would be like starting where you are now and the direction northeast. One end ends in a point and the other is a line. Question 20. How does the introductions of translation in a dynamic environment using dancing and stick figures compare with how you first learned translations? What are the benefits and drawbacks of this approach? I found the introduction of translation in a dynamic environment using dancing and stick figures useful for environment. Describing this translation, it's significant to show them where is the translation all around us. Then the students realize the translation in a different example all around us. Like the drawbacks can be taking long time. Explain the topics to students instead of explain directly. Question 21. Suppose a student has translated a line using a non-zero vector that is parallel to the line. The student claims nothing happened. How do you respond? I try to explain again that the students should pick the line with all the points, then mark vector and then translate. After doing together, I hope the student is going to do the same thing. Question 22. Explains how you could use these pictures to explain to students that a translation would not be the approximate transformation to use to describe the positions of the dancers. Sometimes I watch the dancers, they do the same movement. If they dance and do the same movement with the same direction, it's a translation. However, if they dance looking each other, it's not a translation. We call it reflection. 23. Question. What do you notice about the size and the shape of two stick figures? Find these two stick figures. I drew it before. Yes, this one. This is a reflection. And also I can draw again. Yes, this is a stick. And let's do a mirror line. This is my mirror line. Mark a mirror and then select all these points and then go to the reflection. Reflect, yes. And I got the second one. And the question says that, what do you notice about the size and shape of two stick figure? I noticed that the size of the shape of the two sticks are totally the same. Question 24. Drag a point on the leg of the original stick figure. What happens? Why? Drag other points of the pre-image or the image stick figure. Okay. And I will drag a point on my image. And then, as you see, that there is nothing happen for the second one. What about my image? And also it doesn't change anything on my image. Question 26. Predict what will happen if you drag point B. Drag point B, what happens? Why? Question 25. Yes, I think it does not change anything when I drag a point on the mirror that then which I name is A. Yes, call it A. Question 26. Predict what will happen if you drag a point B. Drag point B, what happens? Why? Let's pick this one as a B. Yes, it doesn't change anything. Question 27. Create a segment joining the hands of the two stick figures as shown below. What do you notice about this segment and this line of reflection? I create a joining the hands of two stick figures. Yes, go ahead. And then they have the same distance, as you see that. Look at this, and then go to this one. Yes, find the distance. 2.04, and what about the other one? Yes, they are totally the same length. Question 28. Have some fun. Create other pairs of stick figures. And I draw it before. I draw a shape, then I reflect on the mirror. It is pentagon. Yes, they are totally the same. Question 29. Based on your interaction with the sketch, provide a definition of a reflection. Arrow points is the same distance from the center line, and the reflection has the same size as the original image. The center line is called mirror line. Question 13. Describe at least 3 different properties of reflection. I can say the 3 properties of reflection is arrow points is the same distance from the central line, which is this one, central line. Reflection has the same size as the original image, and the central line is called the mirror line. Question 31. In order for students to develop an appropriate definition of the reflection from this activity, it's important that they focus in on the important properties of reflection. How can a teacher focus students on relevant properties and assist students in understanding which feathers of the diagram are not important to consider? It's not hard to see the definition of the reflection exploring with these activities. I would like to say that same meaning that I mentioned before question, which is every point is the same distance from the central line and the reflection has the same size as the original image. It's easy to understand and to see on the sketch. Question 32. Let's consider fixed points from the algebraic context. Describe a linear function for which there are infinite fixed points. Describe one or more linear functions for which are 0 fixed points. Describe one or more linear functions that have exactly one fixed point. Okay, I can use these functions. Like it can be as a functions f x equals x is a function which has infinite fixed points. For example, f1 equals 1 and f3 equals 3. On the other hand, if I write down fx equals 3x minus 1. In that time, this is a function which has 0 fixed points. For example, f1 equals 2 or f4 equals f4 equals 11, and also it has 0 fixed points. In addition, if I say that the function is f x equals 3x, it's a function that has just one fixed point, such as f0 equals 0. Yes, it has just one fixed point. Question 33. Under a reflection, there are any fixed points? Explain. Under a reflection, I think the functions is fx equals x because it looks like on a mirror. f0 equals 0 can just be a fixed points. The others are not be the fixed points. This one equals minus x. Yes, it calls just a reflection function. Question 34. Sometimes young students are taught to think about reflection as Phillips. What properties of reflection are highlighted by thinking of reflections as Phillips? What properties of reflections are not made as explicit when considering reflections as flipped? I think it's excellent to see the property that the reflection has the same size as the original image. On the other hand, it's hard to understand for the first time by looking at the mirror. The property is that the reflection has the same size as the original image for the students. Question 35. Consider the pre-image and the image stick figures. Create a description of the relationship between these two stick figures using the synchronized swimming scenario. In the dimensions, the sticks are rotated a vertical axis rotation that pass through the center of C. Yes, this is center of C. Question 36. What do you notice about the size and shape of two stick figures? I have realized that the size and the shape of these two sticks are the same. Question 37. Drag point C and describe what happens to the two stick figures. Explain. I marked the point C and then rotated the stick's figure 60 degrees. I got another stick figure which is totally the same with the first one. Yes, this is the rotated stick figure. Question 38. Drag a point on one stick figure and then describe what happens. The other stick figure. Does it matter which stick figure do you drag? Explain. If I drag the point on it, it doesn't change anything on the other one. Question 39. Question 39 says that if you constructed a circle with center at point C that also passes through a point on the original stick figure, what other points will be circle pass through? Use your DGE to test your hypothesis. If I constructed a circle with center at point C that also passed through a point on the original stick figure, I notice that other point is going to be on the circle as the same place. Yes. Question 40. Describe at least 3 different properties of rotation. I can say the properties of rotations are: the first one is rotations move lines to lines, rays to rays, segments to segments, angles to angles, and parallel lines to parallel lines, similar to translation and reflection. The second property can be rotation preserves lengths of segments and degrees of measures of angles similar to the translation and reflection. Also, the third one, rotations require more than one pieces of information as a center of rotation and degree, whereas translation require only a vector and reflections require only a line of a reflection. Question 31. Are there any fixed points under a rotation? I did not see any points under a rotation. Question 42. To perform a rotation, must DGEs require that you input a particle angle measures. In the earlier exercise, an angle of 60 degrees was used. Describe how this design feature of the technology may influence students thinking about rotation. While I was rotating the stick figure, I used 60 degrees. As I see that on the stick figure, using technology helps me to image what it does mean, so it influences in a good way while students learning. Question 33. Are there particular angles of rotation that would be more or less helpful to use with students? Explain. I think there are not particular angles of rotations that would help more or less while students learning the meaning of rotation. If I say rotated 50 degrees, the students will rotate the shape 50 degrees, which is enough information to teach them. Question 44. Use the language of function, domain, range, independent variable, dependent variable, function parameter to describe the rotation activity you completed in section 3. Every vector can be written in function form. If we say that the function like the fx f x equals ax plus b. In that time, x will be independent variable, fx will be dependent variable, and a and b will be constants, and x will be parameter, which has specific meaning according to the vector's place. Question 45. Describe ways that you can assist students in thinking about geometric transformation as functions. I can use the function while teaching the students. First of all, I should find the pre-image functions, then rotate, and then find the image functions and complete the differences. Question 46. What are the benefits of introducing students to geometric transformation as functions? There are many benefits of introducing students to geometric transformation as a function. Visually, it's important to see rotation. On the other hand, when the students need to find certain points or degrees, they ought to use functions. And pass some questions and go to 54. Yes. The question 54. The question 54 says that drag a movable point on the circle to change the angle of rotation. What changes and what remains the same? Yes, drag it and then change. Why I couldn't? I'm sorry. I should pick it. Yes. When I change the angle of rotation with drag point, the other triangle's place changes, as I see that the size of shapes is still the same. Question 55. Create a circle that has as its center the center of rotation and has its radius point of the vertices of pre-images triangle. What other points must the circle pass through? Why? Yes. Go to the circle and then I noticed that when I dragged many points on the pre-image, there are nothing different on the image. It dragged many points on the image as a pre-image. And I create a circle which is centered on one of the vertices of the pre-image. There's any points which is on the image. And question 56. Adjust the angle of rotation. What do you notice? I noticed that when I change the angle of rotation, the image's place is rotating according to the pre-image. Sorry, it's not that. Yes. And question 57. Track one of the pre-image points. What do you notice? I dragged many points. Yes, I dragged many points on the pre-image. There is nothing different on the image. I did not drag any points on the image as I pre-image. And question 58. Which properties of rotations are highlighted by your interactions with this sketch? I can highlight these properties, which is rotation, preserve lengths of segments and degrees of measures of angles similar to the translation and reflection by my interactions with the sketchpad. Question 59. If you are planning to introduce rotation to students, would you use this pre-made sketch or have students apply a particular rotation to a set of points using their own DGE sketch? Explain the benefits and drawbacks of each approach. I would like to definitely to use sketchpad while teaching rotation to the students. Sometimes we need to give them a chance to discover meaning after some things as a rotation. The drawbacks can be it take a long time how to make the rotations by sketch. Question 16. You can now use the adjustable angle. Question 16. You can use the adjustable angle tool as the marked angle for a rotation to create your own rotation sketch that includes points polygons, swimmers, or dancers. Develop a set of questions to accompany the sketch that you could use with students. Yes, question 61. Open the Stick People Dancing GCP file. Click on the button to see the animation. Describe the ways in which geometric transformations were used in the sketch. Look at this one. And let's animate all of them legs. Yes. Yay, they're dancing. And when I click on the button, I see these stick people are dancing at the same times as they're rotating. Question 65. How can adding animation support or distract students thinking about the geometric relationships in a sketch? When I add some sticks for the animation, and it will be more fun to see all of them are moving at the same time to do same things. They're going to figure out better, in my opinion. Question 66. How could you use of parameters to control the transformation built on what students already know about algebraic function? Using parameter gives us the certain angle and the place of the stick's figure its best way. Parameters affect the sticks while finding transformation. That's why algebraic functions should be known before doing this. Question 67. In the case of rotations, how can using the animations of a rotation controlled by a parameter definition the angle measure impact why students might understand a rotation? Controlling by parameters, students is going to figure out the certain of the angle and see on the other part of sticks. Question 68. Brainstorm another way you could use animation to help students understand properties of rotation. I'm sure that the brainstorms are another way to teach students properties of rotations. On the other hand, visual is the best way to learn topics without just taking on the translations. Question 69. In this case of translation, how can the use of parameter and animation impact way students understand translation? As I see on the sketch, in the case of translation, the parameter and the animation impact weights students have while learning translation well. Question 70. Question 70. Open the file My-Story Transformation GCP. In this sketch, there are 7 pairs of pre-image points. Drag and animate the points to determine what transformation was used to create each pre-image point, if a translation was used. Then also describe the translation vector. If a rotation was applied, identify the center of rotation by placing a point at the center of rotation and the measure of the angle of rotation. If a reflection was used, then indicate where the line of reflection should be located. From A to B, there's a translation. HL is a translation vector. A to B. Go ahead. A to B, there's a translation, and HL, the translation. How can we understand that? Look at the length of them. Different. We can make it the same thing. Anyway, and from G to K there's a translation, and LM is a translation vector. And also we can say from J to N there's a reflection, and the perpendicular line passed through the midpoint of JN is the line of reflection. From J to M, there's a reflection and the perpendicular line passes through the midpoint of IM is the line of reflection. And also from G to the C to D, there's a reflection and the perpendicular line passes through the midpoint of CD is a line of reflection. Any point of the plane can be considered as a center of the rotation, that's O. An angle of rotation can be determined by meaning the angle between HOL and EOF. Yes, question 71. Describe your strategies for identifying each of the Maestri transformation. I use the center of the mirror while identifying the transformation. And question 72. Which transformation was the most difficult to determine? Why? From G to D, there's a reflection and the perpendicular line passed through the midpoint of CD is the line of reflection. Any point of the place can be considered as a center of rotation, that's O. An angle of the rotation can be determined by meaning the angle between HOL and EOF was the most difficult transformation for me. I could not realize that O is a center of them. The last question is question 73. Explain how learning to search for fixed points could assist students in identifying the transformation that was applied. Finding transformation with these points assists students understand how to transform the points or the shapes. When they could do that, they will identify the meaning of the transformation. That's it. I answer all the questions. Thank you for listening to me.